Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. In today's episode 2.4, Introduction to Candid, we're going to be taking a look at Candid's role on IC and how developers can utilize Candid in their project. So to get started, it's good to take a look at what Candid actually is. So Candid is an interface description language that is used to describe the public interface of a service. In this context, a service refers to an application that is deployed as a canister. Typically, public interfaces of canisters are what users and other canisters use to interact with that canister. Candid is supported through the IC SDK through the terminal, and it's also supported through the Candid UI, which can be opened in a web browser. Agents such as Agent.js or Agent.rs can also be used to interact with Candid. The important thing about Candid is that it is language agnostic, which means that it can be used to transfer information between canisters that are written in different languages. It will be noted, though, that you do not need to necessarily use Candid in order for different canisters written in different languages to communicate, as long as they have an agreed upon method of communication. But Candid makes it a little bit easier for developers that don't necessarily have the skills or the knowledge for writing different canisters in different languages to communicate in that matter. So Candid is used for simplicity and supported out of the box by default in projects created by DFX and the DFX new command. So up until now, we have looked at Candid in the Candid UI a few times through the web browser. So when we've used Candid UI, we've used this URL that is returned when we deploy a canister, and typically it is going to be the backend canister that is using Candid. And we're going to see this output of backend canister via Candid interface. And then we're going to be given this URL that is that local development URL with the canister's ID. And so we've taken a look at that a couple times up until now in our developer journey, but today we're going to look at more in-depth of what is happening in this Candid file, and we're also going to take a look at making calls to Candid that are not necessarily done through the UI. So to get started, there are several supported types and values for Candid, and this is used to provide a natural mapping of these data types based on the reasonable choices that are suited for each language that a canister can be written in. And so these are things such as unbounded integral number types, floating point types, Boolean types, textual types, etc. And the full list of these can be found in the Candid reference documentation. When we're talking about Candid types, typically, a developer may not work directly with their program data as Candid values. Instead, they're typically going to be working with their canister's host language. So if you write your backend canister in Motoko or Rust, you're typically working with the data values and data types that are specific to that language. But in some scenarios like debugging or logging, it may be useful in order to see the Candid types in a human readable format, and that is where the Candid textual presentation can be viewed. So here we have a brief example of the syntax of that textual presentation of different Candid types, and so you can just take a look that the values are printed out in a more human readable format as opposed to the Candid binary format, which is this second example here, which is not very human readable, and it would be hard for a developer to take a look at this binary example and be able to debug or troubleshoot things based on these values. And so that is why the textual presentation is a bit more developer friendly when it comes to those different scenarios. So the main portion of Candid is Candid's service descriptions. And so these are going to be used for interacting with the different public methods of a canister. And all of these service descriptions are stored in a file with the extension of .did, which is the Candid file extension. When a Motoko canister is created, these Candid files are automatically generated by the Motoko compiler for those projects, and they are stored in the subdirectory of the project called declarations. When the Motoko compiler automatically generates these files, it's not recommended that these are edited manually, because any changes that are made to the files are going to be overwritten by DFX the next time that this project is built and deployed. So any edits you make are going to be discarded. But for canisters that are written in other languages such as Rust or TypeScript or Python, Candid files have to be manually written or they need to be generated using an external tool. So let's take a look at the simplest service description. In a Candid file, we are going to see this service word followed by a colon and then 2 empty brackets. This defines a single service that has no public methods. And so since this very simple example doesn't have any public methods, it's not very useful. To define a public method, we can insert into those curly brackets a very simple method such as ping. And this ping method has 2 traditional brackets, an arrow, and then 2 traditional brackets again. Both of these sets of brackets are empty. The first set of brackets refers to the inputs that this method takes, and then the second set of brackets refers to the output that the method will return. And so the ping method does not take any data types as inputs, and it does not return any data types as outputs. So that means that it is not accepting any arguments and it does not return any results. So if we want to take a look at a service description that actually takes inputs and returns outputs, first we need to take a look at the code that is going to be corresponding to the Candid file. So let's take a look at the following Motoko canister. This is a simple piece of code that defines 3 functions: an addition function called add, a subtraction function called subtract, and a get function that returns the value of an integer. So in this, we start out with the integer being 0. We define a function that can add values to that integer, a function that can subtract values from that integer, and then a function that can return the value of that integer. So when we take a look at these functions, then we can take a look at the corresponding Candid service description file that the Motoko compiler is going to automatically generate for this piece of Motoko code. So it's going to define a service called counter, since that is the name of this canister. Then it is going to define the service description for the add function, which takes a data type of nat as an input and doesn't return an output. Then it's going to take the subtract service description and it's going to have the same behavior. It's going to take an input of a data type nat and return no output. And then the get function is going to be defined as having no parameters or arguments for the input, but it is going to return a data type of integer as the output. And it's going to do that using a query call. It's going to query the data from that function of get. So this example helps to illustrate that every method has a sequence of argument and result types. Methods can also include annotations like the query notation that is shown in the get example, and query calls are a feature that is specific to the ICP. When we talk about writing canisters in other languages, such as Rust, you can develop your service using the language's native types, and then you can use Candid to write service descriptions, or you can use the Candid extractor tool to generate the Candid descriptions automatically for your Rust code. The documentation for those can be found in these 2 hyperlinks on this Intro to Candid page. As a reminder, this developer journey focuses on Motoko development, so we won't dive into the Rust side of Candid in this tutorial, but in a future version of the developer journey, we will focus on Rust specifically, and we will dive deeper into Rust and Candid. So then when we talk about upgrading a canister, these services defined in your Candid definition also need to be upgraded. So Candid supports service upgrades through a specific set of rules that indicate when a new service type is created, it is able to communicate with any running clients that are using the previous interface description. So Candid service descriptions can be upgraded in ways such as adding new methods. Existing methods can have their return values added to, so they can return additional values. And when this happens, clients that are using the previous interface description will just ignore those additional values. Existing methods can also shorten their argument parameter list, and in that case, clients that are using the previous interface description may still send extra arguments, but they may be ignored. Existing methods can also extend their parameter list with optional arguments. They can change their parameter types, and they can also change their result types. For changing parameter or result types, you will venture into using supertypes and subtypes, and for more information on those, you can check out the Candid interface reference documentation. So as a brief example of how a service may be upgraded, we're going to take a look at the counter example that we used previously. And so we're going to be using that same Candid service description where we have add, subtract, and get. And in this, we are going to define a new type of timestamp. So this is going to define a new type. Its name is timestamp, and it's going to have type nat. And then we're going to define a new method that is called set. It's going to take an input of type nat and return no values. Then we're going to change the parameter input and result types for the add method. In this case, we are changing from type nat to type int for the input parameters, and then the result types are going to return a new value called new val, and it's going to have type nat. Then in the subtract method, we are going to add to the input parameters, we are going to add an optional Boolean value where this method can possibly trap, and it's going to be an optional Boolean of true or false. And we are also going to have the result type of this subtract method change as well. And then the get method, we are going to change the result types, and we are going to include that new type of timestamp that we defined at the top of the file. So this is just one example of how this simple counter canisters methods may be upgraded. Of course, upgrading is going to vary widely based on the different changes that are happening in the canister and how the canisters methods are being altered. So now that we've gone through the basic concepts of Candid, we're going to take a look at actually using Candid. So to get started, we are going to create a new project. And so we are going to use DFX new in order to create this new project. And you may notice that we have the option to view the instructions for DFX 0.17.0 and newer, or older than 0.16.1. In this tutorial, we are going to be sticking with the newest version of DFX, which is going to be 0.17.0 or newer. And so this is going to use a new version of the DFX new command where it's going to give us an interactive prompt that we are using to set up our project's default template. So to get started, we are going to use DFX start clean background to start a new instance of the replica if we don't already have one running. And we'll give that a moment to get everything up and running, and then we can see that the replica is ready to go. Then we are going to use DFX new, and we're going to create a new project called Candid example. And so for this, we can select between these 4 languages for the back end. In this developer journey, we are using Motoko, so we will be using the Motoko backend language. And then for the front end framework, we won't be touching the front end in this tutorial since we are focusing on using Candid, and Candid doesn't have any functionality in this front end example that we'll be using. So we're going to select no front end canister, and then we can add internet identity or Bitcoin as additional features, but we won't be using either of those in this tutorial. So we'll just select enter. And so now we can see that our new project is created, and we will just navigate into that new Candid example project subdirectory. And so we are actually going to be using the counter example code that we took a look at in the beginning of this tutorial when we looked at the Candid definitions that would be auto-generated for this piece of code. So we're just going to go ahead and copy this code, and we are going to paste it into the canister file for our backend canister, so that main.mo file. So if we open up our IDE of choice, and then we can find that Candid example subdirectory that we just created, and we can get that open. And then I will make this full screen so we can take a closer look. And we can see that we have this single source file of Candid example backend, since we chose to have no front end, so we don't have a folder holding the default front end canister code. And we are going to move this over a bit. And now that we have this file open, we're going to close the Explorer here in VS Code. And then we're going to put this code into our main.mo file. So we want to define our actor. Then we want to define the variable called v, have integer data type, a value of 0. We want to define our public function add, data type nat, and we want to give it an async return, and then the functions functionality where the variable v is going to be added to by the value of d. So d refers to the input argument that is passed to this function. So what this is doing is it's taking this initial variable of v, and it's going to add whatever value is passed as a parameter to v for an addition function. And then we're going to use public func subtract. We're going to use that same d nat input data type. We're also going to have this be async. And then we're going to now use v minus the input value of d for a subtraction function. Then we're going to define a simple get function, which is a query call function. So we're going to use public query func get. This is going to have no input parameters, and it's going to return async int, and it's going to return whatever the value of v is. Then we're going to save that. And then if we head back to our command line, now we can dfx deploy. It's going to create our Candid example backend on our local network. And then failed to compile. Unexpected token async, expected 1 token of the following. Let's see, what did I do wrong here? Oh, I forgot a period here. That'll do it. So a colon, I forgot a colon there. So I just fixed that and added a colon and saved it. And now we can see that it can go ahead and install. And we can see that the backend canister is now available through that Candid interface at this URL. But let's take a look at the auto-generated Candid description file and make sure that it matches up with what we expect. So if we take a look at our IDE, we can open our Explorer. If we go into So by default, the Motoko compiler is going to automatically generate the Candid service description file for this. And by default, it should be stored in the source and then declarations file. But it looks like that didn't happen for my project here. So we can force these to be generated with the dfx generate command. And then now we can see the output is generating type declarations for our Candid example backend canister. And now we can use our IDE to go into source declarations, and then we can see the .did file here. And then we can take a look and see that the service description that is defined is reflective of the different input and result types that we defined in our canister. So now let's interact with this service using the command line. So like I mentioned before, in the past, we have only used the Candid UI, which is this URL here. We've only used this UI to interact with our service descriptions. So let's take a look at using the command line instead. So to do this, we're just going to make some calls to the defined methods in our canister. So our add, subtract, and get methods. So let's use the DFX canister call. And we want to include the canister name, Candid example backend. And we want to add, and we'll add 12. So this is going to call our add function. It's going to take our variable of v and it's going to add 12 to that variable. And we didn't define any return types, so it's going to return no values for us. Then if we want to confirm that this worked, we can call that get function to query the current value of our stored variable. So now we'll use DFX canister call, Candid example backend. And then we want to use the get function, and get doesn't require any inputs. So then we'll use get, and we can see that it returns our value of 12 with the data type of int. And now if we want to try this with the subtract function, we can use DFX canister call, Candid example backend, call the subtract method, and we'll subtract 4. And this also doesn't return any result types, so that is going to return just empty parentheses for us. And then we can call that get function again, DFX canister call, Candid example backend, get, and we can see that now that returns 8. And then we can reset the canister's value by using the subtract value again, or subtract method again, so DFX canister call, Candid example backend, subtract 8. And so then if we DFX canister call, Candid example backend, get, we now have a value of 0. So now if we want to do the same functions over here in the Candid UI, we can. So we can call the add function, we can type in the number 12, which is what we want to pass to the function, and we can call it, and it's going to return empty parentheses. Then we can query the get function, and it's going to return 12. Then we can subtract 4, call that function, and it's going to return empty parentheses again. Then we can call get again, and it's going to call 8, or it's going to return 8. So that is showcasing how you can either use the command line to call these different methods, or you can use that Candid UI to achieve the same functionality. So that is going to wrap up today's episode on your introduction to Candid. Remember to like and subscribe to the DFINITY YouTube channel to stay up to date with all the episodes of the developer journey. In the next episode, we will be looking into unit end-to-end and integration testing. So how can you test your canister code and write tests that help predict and catch errors and exceptions in your code? So we'll be taking a look at that in our next episode. So be sure to stay up to date with all things DFINITY Developers. You can stay up to date on the DFINITY Developer Twitter, where we tweet about each new episode of the developer journey. You can also stay up to date in our Discord server and on our developer forum. So that'll wrap things up for today. Take care.